see here in this problem, here for a certain curve, the equation is given as y is equal to ln of cos x, and what is the length of the arc for the given curve in the limits x is equal to 0 to pi by 4. So then how can you find the arc length? So first of all, derive the given equation. So that is equal to dy by dx equal to, so for ln of cos x means 1 by cos x, again derive for cos x function, that equal to minus sin x, that equal to minus tan x. So this is the dy by dx value. Now substitute in the formula for getting the length of the arc. So that is integral of x1 to x2 limits root of 1 plus dy by dx whole square dx. So this is the length of the arc. So here x1 x2 means the given limits. Okay, so this is only for x limits means, okay. Now that's equal to integral of 0 to pi by 4 root of 1 plus, so dy by dx is what, minus tan x. Here square is there, and what, tan square x. So from the trigonometry we know that from the third integral law, that is secant square x minus tan square x equal to 1. So from this secant x equal to 1 plus tan square x, and here square becomes root. So it is nothing but secant x. So that's equal to integral of 0 to pi by 4. So this is whole equal to secant x dx. Now apply the integral for the secant x. So that is equal to, we know that integral of secant x equal to log of base e, that is secant x plus tan x, and here the limits are 0 to pi by 4. Now apply the limits. So then finally we will get log of 1 plus root 2 base e. So log base e means ln, that is ln of 1 plus root 2. So from the options, option is the correct option for the given problem.